We will solve the following exercise. The exercise is the number 2.32. Determine the position vector RAB in terms of its components if A, theta is equal to 30 degrees and B, theta is equal to 225 degrees. Alright, so first I'm going to solve this exercise as fast as I can for the ones that came here to the video for the answer basically, and then I'm going to explain what was needed for me to solve it. Of course, I'm going to explain step by step what I'm doing. Now, right here they are asking for the vector RAB in terms of components. That means that I should look for RAB in the x direction, plus or less, we're going to see that later, RAB the y direction, because we are talking just about a two-plane axis, right? Now, the first situation is A, theta is equal to 30 degrees. So we're going to start with that. Of course, we have a vector which magnitude is equal to 60, in this case millimeters, and we have an angle with respect of the x-axis, which is theta. Alright, so as you may remember, the unitary vector, the unit vector, is going to be equal to the vector divided by the magnitude, right? I can look for the unit vector taking into account just the angle. In this case, the unit vector is going to be equal to the cosine of 30 plus the sine of 30. All right, and this is going to be equal to the vector divided by the magnitude. All right, now that means that the vector is going to be equal to the unitary vector multiplied by the magnitude of the vector RAB. That means that RAB is equal to the magnitude of RAB multiplied by the vector, which is the unit vector, which is the cosine of 30 plus the sine of 30. For when we are multiplying a scalar, which is this, which is 60 millimeters, by a vector, the result is going to be a vector. In this case, you just have to do a distributive multiplication. So RAB is going to be equal to 60 times the cosine of 30 plus 60 multiplied by the sine of 30. And that means that the vector RAB, for when we are talking about an angle of 30 degrees, is going to be equal to 60 times the cosine of 30. We just have to make sure that we are working in degrees within the calculator. So this is equal to 51.96. 15, I always use 4 significant digits after the comma, in the I direction, plus 30, the J direction. Alright, here we have our first answer. Now, for the second answer, all I have to do is to evaluate the same equation, but taking into account the 225 angle. So let me change this. for the sine is equal to minus 42.4264 the j direction, and for the cosine we're talking about the same thing. I direction. All right. So this is the answer for the A part of the exercise, and this is the answer for the B part of the exercise. Now, what was needed for me to solve this exercise? As I was mentioning during the exercise, we just have to take into account this equation, which is the unit vector is equal to the vector divided by its magnitude. Of course, when you are multiplicating the magnitude of the vector by the vector, you are multiplicating a scalar by a vector. So all you have to do is to multiplicate, like if you were multiplicating a parenthesis, a summatory or a subtraction within a parenthesis. So this is a distributive part. This is pretty simple. And then the other term, or the other information that we have to have clear for us to solve this exercise, is that you can't get the unit vector taking into account just the angle generated between the vector and the x-axis, like in this case. As you can see, this is the first component for the I direction, and this is the second component for the y direction. Now, both of the components are positive. That is why I didn't take so much time analyzing the symbol previous to the component. All right, so that is pretty much it. I think this is a pretty simple exercise. If you this is a pretty simple exercise if you have the terminology assimilated. So that would be all, guys. This is how you can solve this exercise.